Here we see an historically accurate representation of a rather negligent scientist doing an experiment without any knowledge of the periodic table, for it hadn't yet been invented.
Well, you only live once.
And that was indeed the truth. You do, in fact, only live once. Our unfortunate scientist had just consumed bromine without knowing its toxicity or its corrosive properties to human tissue. Science. The explanation of the why and the how about the world around us. Science has evolved incredibly since we humans started being curious about the natural world. But before we had all the advanced tools we use today, how were scientific experiments even conducted, you may ask? Well, we had to know the basic foundations about what things were. Disclaimer. The example with our poor dead scientist was of course a dramatization to demonstrate the usefulness of the periodic table. No real scientist from that day would have willingly consumed bromine, as it was widely known by then that it was a toxic substance to humans. Our scientist was just an idiot.
Hey, that wasn't very nice.
Anyway, Dmitri Mendeleev, a Russian chemist, is the main man you can thank for the development and formulation of the wonderful periodic table of the elements. I'm not going to get into some old white dude's life history because, let's face it, that's unbearably boring, and it's not even the point of this video. Good work though, dude. Mendeleev started developing the periodic table around the atomic masses of each element until... Wait a second, there's a lot more going on here. As it turns out, there was more correlation to the different elements than just increasing proton number. Certain groups of elements had similar characteristics to one another. In the modern day periodic table, there are 8 basic groups. Sure, if you want to be all big brain and super scientific, there are 18 total groups, but we're not going to get into that. To keep it really simple, there are the alkali metals, the alkaline earth metals, the transition metals, the halogens, and then over here are the noble gases to the far right. The lanthanides and actinides are the intertransition metals. They're stationed below the periodic table to conserve space. There's even a handy little stair-step line to divide the metals and the non-metals. But wait, look at how organized that is. Oh, but there's more. It's not just the columns that are so beautifully organized, no. There are rows. Behold the 7 periods of the periodic table. I know. Crazy. But what exactly does that mean? Well, my friend, it means that there are periodic trends. As you go up and down, left to right, side to side, back to front, to and fro, and every other which way, there are trends among the elements according to where they're placed on the table. For example, metallic character increases on a downward left diagonal in the direction towards the element francium. Non-metallic character, of course, goes the opposite and follows an upward and right diagonal trend in the direction towards the element helium. Fun fact, most of the periodic table is made up of metals. Different types of them too. There's brittle metals, ferrous metals, light metals, heavy metals...
Did someone say heavy metal?
Yes, but no. Please leave.
The noble gases are generally inert, or in other words, they don't really react with anything. Well, except for your vocal cords in the case of helium.
Now I could go on and on about the intricacies of this marvelous innovation, but this video would be incredibly long. Longer than it already is. The periodic table gives lots of useful information regarding each individual atom. Not only does it tell you the name of the particular atom, but it also tells you the atomic number, as well as the average atomic mass. There are 7 energy levels that just so happen to correlate to the, you guessed it, 7 periods of the periodic table. You can also tell how many valence electrons a particular atom has just based on its group and period location. So, to wrap things up, the periodic table is the mother's milk of chemical discovery. It is the very framework that binds and guides the ordered discovery of chemical elements, describing and organizing their place in the world. Without the periodic table, the chemical world would be nothing but chaos and anarchy. Its absence would render all other chemical discovery very difficult, if not impossible. I personally think the periodic table is an incredible map meticulously constructed to give as much detail as possible about each element, just using an organized visual guide. How cool is that?
I really want an A on this project, so that would be greatly appreciated if I could have one. Thank you very much. I worked really hard on this.